All right, guys, going to do a little bit more graphing of quadratics today. A little extension on what we did yesterday, a couple of new things. So here we go. First thing is x-intercept form. Yesterday we did what is called vertex form and also standard form. So we got intercept form, which looks like this. It's going to be factored out for you. It's going to have an a and an x minus or x plus something, and x minus or plus something else. The p and the q up here represent the x-intercepts, and they're in parentheses, so like always, it's opposite of what you think. I'm going to show you one right here. This one right here, y equals 2 times x minus 4 times x minus 2. Watch how good this is to do with x-intercept form. The opposite of what's inside is your x-intercept. So it's going to cross the x-axis at 4. It's also going to cross the x-axis at 2. Okay, those are the x-intercepts. Now, obviously we don't know what the vertex is, but the vertex is always in the middle of the parabola. So the vertex is going to be right in the middle of 2 and 4, which is 3. So the vertex is going to be 3 something. I know it's going up because there's a positive 2 in the middle. So what I'm going to do is I'm going to plug the 3 in for the x in both parentheses. So it's going to look like this. Y equals 2 times 3 minus 4 times 3 minus 2. Whenever I get there, when I work this out, it's going to be the y part of the vertex. So 3 minus 4 is negative 1. 3 minus 2 is 1. That equals negative 2 when you multiply that out. So my vertex is 3, negative 2, which is right there. I could have guessed that because the 2 in the front, which has got to go up 2 over 2. And then you're just going to graph your parabola. And there you go. Now, if it asks you for axis of symmetry, which it probably will today, your axis, just like it was yesterday, is x equals whatever your vertex x is, x equals 3. Let me show you one more. All right, one more of these. This one says x plus 3 inside, x minus 1 inside, which means my x-intercept is at negative 3. Remember, it's the opposite. And positive 1, those are my x-intercepts. My vertex is going to be halfway between the two. And if you just count, you can figure that out. It's negative 1 something. To figure out what the y is, all I'm going to do is I'm going to plug the negative 1 in where I see the x's in my equation. So I'm going to put a negative 1 into my first x, a negative 1 into my second x, and just work that out. So I get a 2 here, a negative 2 there. That's going to be 8. So it's negative 1, 8, which is way up here. All right, so it's going down. And the reason you just, well, we're going to talk about that tomorrow. I don't want to confuse you here. Okay, and that's all you gotta do. There's your vertex, your axis, like they always ask you what your axis is. X equals negative 1. Same as there, just like yesterday. All right, last thing here. Few words. They're gonna ask you these tomorrow also. Where's the function increasing? Where's it decreasing? Where's the max or min? It doesn't have both. And what's your domain and range? Okay, let's start with the increasing, decreasing. Increasing and decreasing means where's the graph going up and down? If it's increasing, where's it going up from left to right? If it's decreasing, where's it going down from left to right? All right, so first thing I see here is it's going down. If you remember, look at that this way, left to right. It's going down from forever until it gets to there. So we're going to say this. We're going to say it's decreasing. I forgot to hit my marker there, sorry. We're going to say it's decreasing from negative infinity until it gets to, we're always using the x's here. We're just using the x because we're looking the left to right. Because we're looking left to right, we use the axis that goes from left to right. So it's decreasing from negative infinity until it gets to 2. Once it gets to 2, it starts going up like this, starts increasing. So when we say it increases, it's increasing from 2 to forever. So that increasing, decreasing just means where's it going up, where's it going down. Now, next thing is max or mins. The max or mins, it only has one, and it occurs at the vertex, right? The vertex is right here. And because the graph is going up forever, it doesn't have a max, it has a min. So I'm going to come down here and I'm going to put with a minimum. Now, when they ask for a minimum value, it's asking for the y, because now we're talking up and down. Like what's the lowest or highest point? So what's the y coordinate of the vertex? So the minimum value is 4. If the parabola is going down like this, that would be the maximum, but that's a minimum because it's going up. And the last two things, you should be great at this by now, domain and range. Your domain is how far the graph's going left and right, and you can tell it's going left and right forever. Your range is how far it's going up and down. Remember, we always go down to up, and it's going from 4, it touches 4, till it's going up forever. So what you're going to find out too is your minimum and your range are always going to have the same number inside because they're measuring the same type thing, right? So hopefully that wasn't too bad. All we really got today is the x-intercept form and also these words, increasing, decreasing, max, min, domain, range, 6 words. We'll work like we always do tomorrow in class. Look forward to seeing you. Adios.